Good afternoon, everybody. So my PhD project is on the use of fishery byproducts as protein source in animal feed. And the goal of my project is to find a feasible way to go from raw material to marketable products. So why is this necessary? Well, we all know that the fishing industry produces a lot of byproducts. And in Belgium, these byproducts are currently being exported to neighboring countries for very low prices, or they're being thrown away as trash. So we wondered, why isn't Belgium valorizing these products itself? Well, one of the main issues is that to produce, for example, fish meal would require a larger amount of volumes than the Belgian fisheries can supply. So that's why we decided to focus on a Scandinavian processing technique called fish silage. What is fish silage? Fish silage is a low cost, low investment, and easy to produce fish meal substitute. It is produced by adding an organic acid to homogenized fishery byproduct, and this then lowers the pH of the product, which leads to an antimicrobial environment. The lowering of the pH also creates an ideal environment for endogenous enzymes, or the fish's own enzymes, to hydrolyze the protein, so cut the proteins. And this results in a nutritious mixture of whole proteins, short peptides, and amino acids, among other nutrients, such as fats and minerals. Two issues with fish silage is that it contains it has a high moisture content, which decreases the value of the product, and variations in the raw materials also lead to variations in the end product, which is a no-go according to the market. And this is especially an issue due to the mixed nature of the Belgian fisheries. So how did we test this? Well, we looked at we determined the nutritional quality and shelf life of fish silage produced using 4 different combinations of Belgian bycatch species, and each silage increased in species complexities. We did a lot of analyses on these silages, and we will now only focus on the most dominant fraction, the protein fraction, which is about 65% of the product. And as you can see here, during storage, the degree of hydrolysis, so the amount of proteins that have been hydrolyzed, increases over time, which means that a younger silage would contain more whole proteins, whereas an older silage would contain more peptides and amino acids. And we also found that the more complex silages led to a higher degree of hydrolysis. And this is most likely due to a more complex mixture of endogenous enzymes. Whether or not a high degree or low degree of hydrolysis is advantageous or disadvantageous for the silage depends on the use of the silage. But the issue with extended hydrolysis is that it eventually leads to a loss of protein in the form of ammonia due to the degradation of the amino acids. And consequently, we found that there was a decrease in the amount of protein in our silages during storage. And yeah, this kind of sucks if you're trying to produce a proteinous product. So in order to prevent extended hydrolysis, we decided to add a few extra steps to the process. We decided to add a pasteurization step, which should limit the degree of hydrolysis by preventing the endogenous enzymes from hydrolyzing our product. And we decided to add a concentration step. And all of this is now happening on a larger scale in a more controlled environment. And eventually we'd like to test our product as shrimp feed. And hopefully this would lead to a realistic idea to market concept. Thank you.